Okay, so today I'm going over Kruskal's algorithm, which is Kruskal's minimum spanning tree. So I'm going to get to 3. It applies the greedy approach and it treats the graph as a forest. This is my graph. So these are the links. That can be the cost. So think of this as housing development. These are homes. They all need to be connected, hooked up to the electric grid, electric power. So what would be the cheapest amount of cable or the minimum amount of cable to extend so that every home gets connected? Now you cannot have a cycle. That means that you cannot connect the home like G here and then come back and reconnect it. So these are the lengths I have here: I to J, which is 0, G to H, which is 1, E to F, which is 1. So those are the minimum. Now the way this algorithm starts, we start with the least value here. So I'm going to highlight I to J. This is 1. Now, are there any more zeros? No. So what happened is, so there is a 1. So I'm going to attach this one. So this is a 1. Okay, is there another 1? Yes, there is a 1 here. Alright, so I'm hooking up these ones, and there's another 1 right there. So far I have connected I have I and J. I've calculated G and H, E and F, F and A. Okay, so my next value. Now I can't have a cycle, so therefore let's pick up 3. So I will hook up D and I will take this length, D and B. So that's okay. That's my next length. Now, how about, so I can also take C and J. So G and J is fine. When I take C and J, that will be fine. Now, I can do H and C, or I can do G and I. They both 4. So I use this one. Alright. Now, does this, okay, is every home now has a link. Okay, so D is attached. See here, if I took out E to D, that's my third one. See, now I cannot take A to D because that gives me a cycle. I cannot take A to B because that forms a cycle. I cannot take I to C, that forms a cycle. Or either H to C, that forms a cycle. F to D forms a cycle. So anyone that forms a cycle, I can't use it. So I end up with this spanning tree. So this is my, so every home is actually connected. See, so if I look at this, there's 1 here, plus 1 here, the length. There's a 3 there, plus 3. Plus 1, plus 4, plus 0, plus 2. So I end up adding this. I'm going to get 2, that's 5, that's 8, 9, 13, 15. So I have 15 units of whatever, whatever those units are. So feet or miles of cables. And that's it. So this is a really simple and a very powerful algorithm to actually, compute the minimum spanning tree. So as you can see, every one of those units or vertices or homes have been included in the final graph. And this is known as the Kruskal algorithm. And thank you.